Okay, this is section 7.5, video on properties of logarithm. We have no vocabulary, but our objectives are simply to simplify and evaluate expressions using the properties of logarithms and simplify and evaluate equations using the properties of logarithms. So basically we have an expression and the equations. So properties of logarithms simply mimic properties of exponents. So you've got to know the product rule, the quotient rule, and the power rule. Now, here they're going to prove to you, and we're not going to go through this proving, I'll let you look at it, and they said if let b to the x equal a and b to the y equals c, then using the definition of logarithm, they could solve for x and say x equal log of a base b and y equal log base b of c. Basically, they just took the exponential and moved it to a logarithm. And then they use substitution and they're going to prove the property. So basically what the property says, if you take the logarithm of a product, it's going to be the sum of the logarithm of its factors. So you have to first of all identify it's of the argument. So in this example, log base 2 of 30 really can be written as log base 2 and the argument is 30. But what they did is they broke down the argument of 6 times 5. So it has to be the product of the argument. And then the property says, then you can break it up to 2. You take the first one and you take the sum of the 2 log with the same base of the 2 arguments. And likewise, you can go backwards. It's important to know that this is not the product property of logarithms. It has to be the product of the argument, not the sum of the argument. And then, just like an exponential, you have x to the m times x to the n. It's the product of the exponents. And then the property says you add the powers. Where here it says you add the logs of the 2 separate arguments. Okay, so let's look at an example using this. So it says use log base 4 of 3 to make equal approximately 0.7925. Use that to evaluate log base 4 of 192. So we're going to do log base 4 of 192. All right, so first of all, I'm going to take 192, and what they did is they factored it to say 64 times 3. Okay, and we know 64, you should know if you don't know, is 4 cubed. So I can rewrite this to say log base 4 of 4 cubed times 3. That's what 192 represents. Because I have the product of the argument, the property says I can say log base 4 of 4 to the 3rd power plus log base 4 of 3. Now they told us to use this as approximately 0.7925. Isn't that what this is here? So I can replace that with 0.7925. Now, if your base of your log and the base of your argument are exactly the same, this equals to the power 3. So 3 plus this is 3.7925. And that's how we use the product property to break it down into 2 separate logs, and then we can calculate this without a calculator. And so the next property is the quotient. Again, it says if you have log base x of the quotient, remember it's of the argument, it's got to be one term. Again, with the products of one term, then you can change this to say log base x of a minus log base x of b. Remember when you had x to the m divided by x to the n, what did you do? X to the m minus n. It had to be the quotient of 2 exponents, and then you took the powers and found the difference, m minus n. Order matters. Same thing here. You have the quotient of the argument, a over b, and then it's a minus b, the same order, because order matters. So let's look at the example in the book that they give us for the quotient. So they go here and they prove it. And I don't think you really care on proving how they got the formula, but you can go through this and we can talk about this in class if you're interested. But so basically, there's the quotient property, what I just told you. So if you have log base 2 of 5 divided by 6, you can take log base 2 of 5 minus log base 2 of 6. Okay, so let's look at this quotient property here. It says the pH of a substance defined as the concentration of hydrogen ions, H plus in moles. It is given by the formula pH equals log base 10 of 1 over H plus. To find the amount of hydrogen in a liter of acid of rain that has a pH of 4.2. So pH is your Y value. This H plus is, these are just because they're more than one variable, they're just symbols. They're saying this, think of this as just the variable H. But they use H plus to identify that it's a hydrogen ion. This is a chemistry problem. Okay, so they want to know what is the amount of hydrogen ions when the pH is 4.2. So you just put 4.2 into this. We need to solve for H plus. So because I can change this to 2 logarithms, yes. So the log base 10 of 1 using the quotient rule minus the log base 10 of H plus, which is our variable. Now, because this is log base 10 of 1, this equals to 0, right? Because 10 to the 0 power equals 1. So then we have 0 minus this, which equals 4.2, equal negative log base 10 of H plus. They divide both by negative 4.2, and they change this to an exponential. So remember, I say find the symmetrical property and flip this, so then it's 10 raised to the negative 4.2, and you can put that in your calculator, which gives you about this many moles of hydrogen in a liter of rain. You can check it by putting it back in here, and you should get 4.2 equals 4.2. Okay, so it's just solving. So the power of property of logarithm is similar. So basically what it says, if you have log base b of m raised to the p, it's going to equal to p, the power, times log base b of m. So if you have log base 2 of 6 raised to the 5, you can take that exponent and put it out here and do 5 times log base 2 of 6. So let's use example 3. Given log base 2 of 5 is approximately 2.3219, they want you to approximate the value of log base 2 of 25. Well, 25 you should know is a perfect square, so they just took this and rewrote it to log base 2 of 5 squared. Using the power rule, this 2 comes over here, 2 times log base 2 of 5. Well, I know I have an approximation. It's 2.3291, or 2.3219. That means multiplication, so that times 2. We can do this without a calculator. We can also use these to solve equations. So here I have 2 logs, the sum of 2 logs equals a number. All right, I have the same base. Remember, my argument's x, my argument here is x minus 9. So it says I can go back and use the product rule of logarithms, which says because they're the same base, I have the sum of these two of the same base, I can take the product of the 2 arguments. So this becomes log base 6 of x times x minus 9 equals 2. Then I change it to an exponential function, which says the argument, which is x times x minus 9, is equal to 6 squared, which equals 36. They distribute this x, they move the 36, you've got a quadratic. Now it's just factoring and solving. Again, we have to check both. Here we get 2 equals 2. Here we get a negative log, which is undefined, so this is an extraneous solution, or it's undefined. So you're just using the properties which mimic exponents, and you got to know them. And it has to, remember, it's a product of the argument, the quotient of the argument. It has to be one term in each, otherwise the property does not exist. So you cannot say the log base 10 of x plus 2 equals the log base 10 of 2x or x2. That is not the property, because you have more than one term as argument, and the property, if you had 2x, then it would say log base 10 of 2 plus log base 10 of x. All right, that's what the property says. All right, do the practice problems. We'll see you in class.